Hello, hopefully my lighting behaves. Um, right, we're back working on my command line interface calculator in OCaml. So in the last video, which I will link in the description, I guess, I implemented the parser. What a parser does for a calculator, it converts the tokens into an abstract syntax tree. And for those who don't know what a token is, it's the product of a tokenizer. It takes like a script or like an input and then it tokenizes it and converts it into token. Anyway, I'm not going to go into detail of how the whole thing works. But today we are going to be working on the evaluator, probably the easiest part, and then I might even do a bit more. So let's have a look at our code so far. This is the main function. As you can see, we run the tokenizer. We are still tokenizing this thing to start. This little string, which is the expression, the mathematical expression, 6.9 times blah, blah, blah. And you can see here we tokenize it, print the tokens, and then we parse it with our parser. Yep. And I have my tokenizer here. Pretty simple. And then the parser is probably the more complicated part, as you can see here, because like there are layers to it. Not like terribly like complex, like logic wise, although it is a bit mind bending. But just like in terms of like how much you need to write, I guess, and like it can be a bit hard to like visually parse. But anyway, once again, I already did this in Haskell, so this is the parser in Haskell, and then I also have the evaluator in Haskell. So I will largely be copying my own code because I did code this as well. And yeah, let's just get straight into it. So we have a parser tokenizer and now the evaluator.ml. Let's go ahead and add this to our hooks, and I'll also change the part. Oh, what the hell? Okay, that's a bit strange. What the hell? Okay, I'm going to move this up here. What just happened? I'm very confused. Okay, we're chill. Right, so HJK, nice. So we do need our module. Actually, I don't know what we need. So in this case, we don't actually define any structures, any product types, I guess you'd call them. So that's fine. We don't need to go ahead and define any modules in this case. We make use of do notation. That's fine, and fmap. So it should be fairly straightforward. Why can't I scroll sideways? GitHub, what the hell? Okay. And we do make use of the parser, but in OCaml, you don't need to include them. You can just access it like this, tokenizer.token. So we'll do parser dot whatever. Right. So first function then is evaluate, or the core function. Although because of again order matters in OCaml, again because from the last video, I do need to actually do this in reverse order. But anyway, we'll do this first. So evaluate takes in an expression. An expression comes from, I believe, parser. So parser dot expression. And we'll give it a name. Here we just match it directly, but we can't do that in OCaml. So I'll need to do this. I think I'll do like this then, right? Parser dot expression. Or is it expr? It's t. Okay, so we parser dot expression dot t, I think. And I can verify this because in my expression, I use a tokenizer dot token dot t. Yep. A bit confusing for the unacquainted, but whatever. And then we return an either string or double. So in OCaml, that would be like a tuple. Actually, I can't really remember how you do this. Is it like parse result is what? Left is that, right is that, and the result. Okay. Oh yeah, and I don't need to name the type, the return value because it's a type. Man, so it's a string or a double. So just string, float in this case because OCaml floats are doubles, I think, and then result. result type. Okay, cool. And then we just go ahead and implement it. So I don't think it's recursive. It is recursive, never mind. So we have to define this as well as rec for recurse. And do we call these? We do call these, but these are generic functions, so it should be fine. Yeah, that's fine. So, because if you remember, well, if you watched the last video, you can see that I used and, this thing here, the and keyword, to kind of like connect all of these, but I shouldn't need to do that here, because these functions down here can be standalone. Logic, right? So equals, and then how do I match this? I could do like match expression with, but I think there's like a function keyword as well I can use. There is, but I didn't use it here. Yeah, I said that in the last video. I said I would actually also see if I can make this code cleaner as well, because I think I can do something like to make the pattern matching a bit more clean. But I will do that later then. For now, then we'll just do a simple match expression with, and then go ahead and implement the matches. So first one, we have an xp num, expression number. So from our expression class, or module, sorry, or even, yeah, I think this, right? This thing. Um, so, um, the type comes afterwards. So would it be, no. So it'd be, parser dot number, I think, followed by the actual number, which we'll define as n. And then if it matches this, then just do write n, whoops, which in OCaml is okay. Because write is success in, oh, sorry. In Haskell, the right, again, this is so confusing. Like this trips me up. In Haskell, the right side is the okay, and the left side is the error. But in OCaml, it's opposite. So we should have a float here, and then the string is the error on the right side. So yeah, we return okay n. I think. Do I need to wrap this? I'm thinking of like bloody Rust now. I think it's just okay n. Yeah, just okay n. Okay. Um. Yeah, and then just check that this. Before I did tokenizer.token dot parentheses close. Okay, no. So it needs to be parser dot expression dot number, I believe. Okay, seems good to me. So like all of these names, like although they're under like a type binop, type unop, your operator, type T, these actual identifiers here, like binary op, negative, subtract, all of those are like under the same namespace. So if I wanted to like access subtract, it would just be it'd be expression subtract, or for like number, which is part of the T type, then same thing. Which is a bit like, I don't know how I feel about that, but whatever. It's still better than Haskell's one, where everything is just global. And then, yep, just add more branches here. So if it's a parser dot expression, can use autocomplete here, dot binop. Yeah. And then it takes three things. So for this, because it's like a product type like this, I think I need to define it like a tuple. So we have left, well, I'll do left, operator, and right, just for clarity. I think this is correct. Obviously, I found out when I try to compile it. And then we have do notation here. So for OCaml, I don't need to do notation. I can just do, well, I need to unwrap it though. That's the thing. So I think I do a let statement like this. Let L equal evaluate left, sorry, L prime, like so, semicolon. The semicolon does not is still the same. It's not the same as in procedural programming. It just gives like the illusion, I would say, like this. I think because what this does is like the let statement. It unwraps that, basically just the same as this. Or like using a monadic, like the in the Haskell boom 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 operator. But then that also means that I should define this first. This might be global though, so I don't know if I need to even put this like in one particular. I don't know. Just for clarity, I'll just put it here as well. Yeah, because we are using the result.bind operator, and we can like there's like some funky thing here that I need to define. I don't fully understand it, but that is how it works, or that's how you use it. Sorry, and then we return this. Okay, so we're going to call get a binary operator. Um, huh? Wait, what? I'm just, I actually don't even understand why I put here. So get binary operator that passes the operator. This curries it, so it returns a function that takes double and double and returns an either string double, and then that's our return type. Okay, that's fine. So I don't know how currying works in this language, but I'm going to assume it's the same for now. In which case, I do the same thing. I just do get binary operator, or I'll do binary op, and then call that on our operator, which is a parser.expression dot whatever, and then not equals, and I pass in left and right prime as the args. That should work. And I don't need to do anything here because this will do that. Yeah, that system will work for now. And then the other one, it's like as a unary operator. So I'll just copy this actually. Yeah, so unary op with our just operator and the value, right? So value, not C, CRW value, right? And yep, pretty much same thing. Just value prime equals evaluate v, so value here, and the semicolon, and then we're just returning get probably unary op, right? Yeah, on our operator, and then we apply that to our value prime. Pretty straightforward. So that's our evaluate function, and then we should define the rest. So get binary, sorry, let get binary operator, or binary op. Sorry, it takes in a operator. So we'll do like this, operator, which is of type, and this depends on our class here, on our module, sorry, a bin op. So an expression, a parser dot expression dot bin op. That is the type, I believe. And this will return a same thing as the other thing, float string result. Right. I don't like how long these type names are, like these declarations, but I suppose it can't be helped, or maybe it can be helped. I'll find out later. And then match operator with, and we have 4 different possibilities. Right. Actually, I don't even know if I need to have this. I think I might be able to just to get away with this because like it knows what the type of expression is. So like it may be able to infer it, and then I don't need to include it. Um, can I test this? I'll test it later because I can't compile it now without messing everything up. So I mean without like ignoring this file and whatever. code now, optimize later, or clean later. Obviously, clean as you go along if you can, but like learn how to clean it later. So it's a parser. Yep. Dot expression. Dot what, like add? Yeah. So adds, subtract, etc. So if it's add, we just do an fmap. Now, how do I fmap in this language? Because I want to wrap it in OK. Like basically just return the plus operation, but then wrap it in OK. And I don't know if OCaml has such an equivalent. So let's of course ask Claude, our friendly neighborhood local teacher, whatever. Not really, not local, cloud based, whatever. Right. So what what is the OCaml equivalent of this Haskell expression? For those who are new, I'm not using Claude to generate code for me. I use it as a learning tool because this is my first time using OCaml, and I just don't know the syntax. And I could read the docs, but I'm lazy, let's be real. This is a partially applied plus compose. Yeah, I know it is. In OCaml, there's no built-in fmap, so you have to explicitly. Really? Why is there no built-in fmap? The direct equivalent depends on context, but the most interesting translation. Yeah, I mean, it depends what you want to do, yeah. Or if you specifically need either style. Yeah. Okay. So if I were to keep this as close as possible, I would have to define an fmap OK, and then I would have to do this. This is an anonymous function. Which takes an argument fmap? Must do. Okay. But okay, so the key thing is that plus is indeed a function I can pass, like in brackets. I think. I think like I can curry that. So how would I write this here? Yeah, because it returns a function that takes in a double and a double. Yeah. Do I even need to like define my own fmap here? I think I can just do okay. Um. mm, There's not a great way to do it, is it? First of all, do I need to define it like a fun as well, like an anonymous function, and then say, oh, hold on, my return type's wrong here. Oh man, this is quite complicated now. Okay, so what is this? What's a function signature then for this? Because I'm applying it to left and right. Like I'm applying the result of get binary op to left and right. I'm not passing left and right as arguments. I could do, but I prefer not to if I can avoid it. So what a function which takes two arguments, a and b, where I'll do x, y, and then you just return x plus y. Like I could do that, but that's the same as just plus, right? Like that. But the main thing is that it needs to be an OK plus. But I can't do that because it needs to fmap into the OK. So to do that, yeah, I guess I can't really do much about it, can I? Okay, fine. So for now, again, I'll see how I can improve it later, after the fact. But for now, I'll just say it's an anonymous function, takes an x and a y, where x is a float and y is also a okay, also a float. And it just returns OK x plus y. Pretty straightforward. Do I need to do result.OK? I don't even know what. Yeah, yeah. Okay, fine. That seems to work. But I am curious. Nah, later. Okay, so subtract. Same stuff, just minus instead. Literally the only difference, I'm pretty sure. And then likewise with multiply, it's going to be times y. I hopefully don't need to worry about overflow. And then for division, we call our safe division function, which we'll define in a second. So we just say xy. Ooh, can I do this? Does OCaml support inline functions? Inline binary functions? Like Haskell does with backtick mod backtick? Yes. Only for existing functions or operators. OCaml uses a different syntax. What the hell? Okay. Claude just corrected itself, I guess. There's a pipe operator. Like at and in Haskell? What? What does ampersand do in Haskell? I don't recall using that. Huh? Okay. So you can define your own infix operators like this, but you cannot use backticks to put them between. That's a shame. But you know, fine. Fair enough then. In which case you have to do it like this. Safe div. Yeah. I mean, Haskell. By the way, I know Haskell has like a lot of controversial features, but I really feel like infix functions is a really cool feature, and I also think that the $sign is a really cool feature because it would mean that I don't need to like care about. So I need to change this as well. Change like, yeah, like just no brackets, right? Well, yeah, man. I do like Haskell. I must say, as much of a pain as it is in some cases, in some areas, it definitely has its benefits. So this should work here. In fact, I don't even need to wrap this in OK because safediv will return either type. In fact, I think I can just outright do this, and that's fine. I don't think this function signature is correct, but I don't know how to write it out properly yet. So let's ask Claude. What is the OCaml equivalent of writing type signatures for higher order functions, assuming OCaml even has them? Like in Haskell, you can do double to either string or double, right? Please have them. It does. Okay, thank God. In OCaml, it's the same thing. Sheesh. Let's go. Perfect. So in that case, it takes in a float to a float to a string. Perfect. So that's one thing that's actually the same. Takes a float to float. No, in this case, it's a float and a float. Perfect. Okay. So we define safe div. Safe div takes in an x and a y, I believe. Yep, which are just both doubles. So x float. Sorry. Boom. Yikes. Yep. Probably less effort to just write it out. Honestly, equals. Oh, sorry. It returns a type. Float string results equals. We don't match anything. In fact, we just do. How did it here? I did pattern matching. Okay. Interesting. I mean, I could just say if x equals 0, then but you can't early return, can you? Interesting. Like, yeah, I wonder if pattern matching is the cleaner thing here. I guess it is. But like but like specifically in this case, I've already defined x and y or like anyway. So I might as well just do an if statement. I actually don't know how you do if statements. If okay, seems so good so far. This will be n and d for denominator and for numerator. So if d equals 0, then I believe it uses ternary if statement, like if statements as expressions. So if d equals 0, then an error, right? So that would be error division by 0, else okay and over d. Yeah, look good to me. And then I also need to get unary operator here. So let's get unary op, which takes an operator, parser dot expression dot unary operator. Loving the LSP, and this returns a float2 float string result, I believe. And then, yeah, there's only one thing it can be, but for the sake of, keeping it open to future expansion, I will just write out the full case statement anyway. Negative. This is so it's a function that takes in an x, which is a float, and it returns an OK, just x times -1. And I don't know if I need to wrap this in a bracket. Does OCaml have the same rule for negative numbers, where you need to wrap them in brackets? Because if you see in Haskell, I need to do this, even though most people might think to just like that you wouldn't need to do that. Same deal in OCaml. I wonder why. I mean, obviously parsing ambiguity for like white space, but like, what the hell? Negative dot for negative floats. That's interesting. That's very interesting, actually. What the hell? So it's like a special operator. Anyway, so this is necessary. In fact, can I just do negative x? Oh, so actually it is double in this case. So I think I do actually need to use this, don't I? What the hell? Okay, so by logic, if you can do this on that, I assume that I can just do this, and that should be okay. It's very weird, um, but that has to be how it's done. Like, what the hell? Okay, and that's it. Our evaluator should be finished. Let's just see if it compiles, right? So let's go ahead and duplicate this. Tab, and I believe, I don't know, I actually don't know what the commands are. Is it June build? Or June exec even, for execute. But let's see if it builds first. Okay, syntax error on line 26 in our evaluator, I assume. Yep. Line 26 has this. What's wrong? Hopefully it's not because I have issues with how I set this up. Characters 4 to 5. So it must be expecting more here. But then like it gets this instead. Okay. It's a syntax error, so I'm not really sure what I can do if I don't know the syntax well. Why would this cause A syntax error. Oh, you use in. Oh, that's right. Okay, fair enough. Fair enough. Fair enough. Yeah, I can't remember. I can't remember when you actually use the semicolon. Um, but unit returning expressions like print underline high. Ah, okay. So you only use a semicolon if it returns a unit like this. Which in that case, I guess a semicolon is actually equivalent to like this operator in Haskell. Whereas this one you use let, which is in, because like you use in anyway, right? Okay, interesting. Once again, OCaml showcasing how it's not actually procedural at all. It's just has some syntactic sugar for it. Okay, line 29, which is the end here, because same deal here. This should be in. Those. The concept 0 has a type. Right, so it needs to be a float. So I'll do dot. That should be good enough, or like explicit enough, as opposed to 0.0. The value n is type float, but an expression was expressed of type int. Okay. So does the division operator only work for integers? Uh, and what is the division operator for floats? They are distinct. They use slash dots. Whoa, what? Wait, so all of the operators use for floats, you need to use the thing and then with a dot. That's so interesting. That's actually so interesting. Like, obviously, it's less convenient, like for a human just who just wants to read it, but it is a way to avoid operator overloading. Yeah, I don't know though. Like in Haskell, you have the number type class, but OCaml has no type classes. Damn, that's so weird. That's so interesting. So how about equals then? Does equals also need it? I assume no, but let's ask anyway. Oh, oh, well, huh? What does OCaml use for not equals? Wait, so OCaml actually doesn't even use double equals; it just uses single equals. That's really interesting. This reads so badly, like a bloody English sentence. Um, do I do this? I'll do this. It's idiomatic. Huh? What? Wait, so this is the inequality operator, and this is for structural. Dude, what the, this language? Okay. Who made this language? Because this is messed up. This is actually messed up. So I use a single equals for inequality, but it looks like assignment. No, it looks like assignment as well. Guys, people who swear by OCaml, what the hell is going on here? Like this language is actually taking the piss. Okay, let's build anyway. Should work now. And that's just something else, of course. Nope, it was successful. So this is all very interesting. I wonder how does this operator, please Claude, let me type, handle division by 0. I assume it might even return infinity or like a float nan, or just an exception. No, it is infinity. No exception thrown. Issue division by 0 does raise division by 0 though. Okay, I thought so, because floats can represent infinity, but in our calculator we do not want that to be the case. So let's do execute. Um, oh boy. What am I executing here? I think it was like dot slash bin slash main dot exe, even though there isn't an exe there, but I think, right? Is that true? Bin, yeah, like there's no exe here, so I don't really know where that's coming from, but Oh, here. Oh, okay. Okay, never mind. It's relative path into default. Fair enough. So let's go back. Everything works now. I just need to actually write it here. So for the OK condition, we just expand this, right? Same thing as we did here. And then we need to match. It's 4 spaces. Yeah, it has to be. So we do begin match, but we're matching against the evaluator dot evaluate on our AST. Yep. With. Make sure to write the end case here, and then if it's okay, result, I guess I'll call it. Okay, results. Then we just do the same thing we did here. Yeah. We print end line, show. Don't need this in this case, so I can just DA boom. We're printing the results, that's it. So just print results, because it'll be a double in this case, and for the error it'll be a string. So of course, just printf error. Yeah, same as the other lines really. And actually, can I open printf here? Just so I don't need to do this, I can just do like this. It's a bit cleaner. Okay. There's definitely like some way I can use monads here for this to be a bit better, but for now, let's go ahead and do execute, see what happens. Print end line, did you forget a semicolon? I probably did. Here. Yeah. Evaluator.evaluate. Did I make a typo? Of course I did. When do I not? I swear it's my keyboard, guys. It's not my fault. Evaluate. Okay. Man, I need to get like my LSP installed properly so I can actually see errors before I compile. The value result is type float, but an expression was expected of type string. That's great. That's awesome. I forget if there's a show function or like there's like a way to convert. I think OCaml convention, some types, result types, pattern matching, take while, drop while, read. So for read, you use of sequence and to sequence. So I'm going to take a wild guess that I would use float to string. Ah, yeah, here, float of string. So is there a string of float? Surely. Like that just makes sense. So string of float results. Take a gamble here. Hopefully things are logical, expected, etc. Looks good. Negative 29.9. I believe this is correct. Let's go ahead and verify this because I can't actually remember what this is meant to return. Thank you. Google, what do you say? That's not what I copied. Need to make sure I'm copying to the right register. 6. What? Okay. Yep, it works. There we go. Our calculator is finished. Well, it's not finished because it takes in it doesn't accept any expressions, but the chain is complete. It's functional, I should say. Not complete, it's functional. Cool. So let me actually just check in Haskell how I went about the main logic first of all. Why can't I scroll to the left? What the hell? Yep, so like main, don't ask. Yeah, I mean this had a bit of a goofy control flow anyway. Let's just start with taking input. So we need to, of course, get args. So how to get args? CLI args. I assume it's a function of some sort. In OCaml, sys.argv in a string array. 0 indexed where index 0 is a program name. Or if you want a specific index. Huh? Oh, that's cool. So they use dots, like brackets thing for array indexing. Or args1. Interesting. Okay, fine, sure. Yep. Length of args is more than 0. Head of args is an element of tree values. That's important. If there's no... I can't actually remember. If I just don't pass anything, does my thing fail? Like, did I even consider that for my Haskell one? Where'd I put it? Probably in archive now. Um, yep. Let's go ahead and... How do I run this? Speedy builds? I guess I have to do that. That's there. Okay. So / calculator, Control V. Oh, I run it and then I pass it like this. Oh, that's right. That's right. Never mind. I don't even need to pass command line arguments. I need to read from the console in this case. Also, it's a loop. So this is recursive. Recursive main. Hopefully that's okay. So first of all, we do print. Hopefully that was fine. We print this. Semicolon, and then we how to get command line user input. Read line or sys.argv. Okay. Like SGD and vargs and Rust. That's how Rust does it. Okay. In my case, we are doing read line. Print string. Okay, sorry. Print string. Why is that print string then print end line is just like not print string end line? Like this language conventions are just so weird and kind of inconsistent, I feel. Okay, so let's input, yeah, why not, equal now, so what, I need to read line? Read line and I have to pass an empty argument? Why? Okay. Yeah, why? I don't know. Right. Then you got this is semicolon, right? Yeah, that's fine. Okay. So do that. Make sure to flush it. I forgot why I need to flush. I think because like it just didn't show for some reason. And yeah, then it takes the input, so I can replace this with input, and that's it. So if it manages to finish everything, then this is horribly nested right now. But what it would do is it would just call itself. So can I call this main? Or does it have to be like by convention some empty thing? Let's see. So June exec for execute. This kind of function. Oh, I said where? This kind of expression is not allowed on as right-hand side of let recurse. So the error is the issue, I assume? Because the error doesn't recurse. Yeah. Yeah. It's just really annoying. So I need to like kind of do this for each error condition as well. So it never ends. So like never doesn't call main, I guess. Uh, oh boy. Man, these error messages are not It says from characters 6 to 24, so I assume 6 is also an issue. But why? Okay, let me do this. Let me do that and say let boom boom equal main. See if that makes a difference. Unbound value main. All right, because I need to put this below. Yeah, I think this is the fastest way to do it. Okay. Look at that nesting, man. Oh boy, that just completely effed up everything. Okay, in that case, I'll just do this. No. Doesn't seem to like it anyway. Right. Holy moly. Let's take some proofreading advice from our good friend, once again, our mentor, Claude. So, how do I approach this behemoth? Is that even how you spell behemoth? Pyramid of Doom. Use let bindings, as I thought, okay. Yeah, the thing is, I do want to actually print each step of the way. Um, like I want to print the output for the tokenizer and the evaluator, which is why for Haskell I needed this like really I mean not unconventional, but like unusual if you are like not used to functional programming. Like this is very strange. Um, but whatever. Oh, there is a result map. What? What? Wait, so there is a map in. Are you serious? Wait, so then that means I can okay, I'll come back to that. Um, okay. So first of all, I'll fix this. Um, do I even need to? Well, no, because I need to. I need a name. So I need to have this. Like that's like an argument. I don't really understand how that works. The value made is type unit to but the question that was expected of type. Okay. So I need to call like this, I assume. Oh, that actually works. Okay. No, do not post that. Paste that, sorry. Paste this. Cool. 2 plus 2. 4 points. Sure, why not? Great. If I do something invalid token C. If I do something like bogus like this, unexecuted token. Nice. So it fails on the parsing phase. And if I do like 3 over 0, division by 0. Perfect. So it works. Definitely works. So I'll go ahead and commit this for now. So git add, git commit, finish functioning evaluator, and push. Okay, that took us 49 minutes. Not too bad, honestly. And now for the cleanup. Oh boy. Huh? Debug print helper. How does debug print helper work? Okay. Um, how would a debug print helper work? Oops. No Facebook, go away. Let debug print show fn. So pass the function. Wait, what? So this is a function. Where is it? Yeah, this is a function. Okay. What? How's that a function? I'm very confused. But so then it's actually like this. In fact, wait. So is it saying that this is equivalent? No. Well, I'm guessing like it takes show and then it passes a type this. Like, is that how that works? Although then again, like it's an external plugin, so maybe it just uses some like custom like Lisp you can define whatever you want. Um, hmm, hmm. I don't know. Um, yeah, how's this different? Let tokens equals debug print tokens. So it just returns the same thing. Slots and transparently, same idea as Haskell's debug trace. Why do I need to do that though? I could just end it in a semicolon. What? So weird. Um. Anyway, so it's not ChatGPT. Claude is suggesting I just do this. Let me just quickly kind of understand how this actually works. Okay, so this is the basic idea. Then your main becomes print string run input. Oh, okay. So I put this into a separate. Oh, Scheiße. I put this into a separate function called run. I match it, and then okay, so I guess with this, if there's an error, it will just return early. Like conceptually, it will return early. Um, make sure my camera's actually pointing at me. And then printf final results. Yeah. Okay, that seems quite cool. Why did I make this so complicated? Like, I'm not wondering if I even had to do this in the first place. Like using lift.io from system.io. Or sorry, from this class here. Like, could I have just? Well, okay. Let's see how this works first of all, because I will just make it things a bit clearer. So we need to have our function run. um, is recursive, so I do need a third function. Okay. I can't. Do you want to call it run main? I'll just call it run or calculate. I'd say. We pass in our input into calculate, and it returns the results. So that should be fine. That's a fitting name. Also need to remember to define this. So let equal results.bind holy clutch memory or like whatever. Yeah. So it takes an input, which is a string, and returns either a float or a string result. Nice. I know I don't like need these type signatures, but I just can't imagine code being that readable without them. Like even especially for functions. Like we're so used to saying function type signatures. Like to make that implicit just feels really wrong. Like in Haskell, it's good practice to separate it. In fact, I have a question for Claude here. Yeah. If Haskell was invented before OCaml, why does Haskell feel so much cleaner? Like type signatures are separate, go on separate lines so you don't get a monolithic function declaration. I need to know. Haskell actually came after ML. Oh, that's right. So OCaml was like an extension of ML in some ways, if I recall correctly. So ML 1973, and about the same time as OCaml's direct ancestor, Camel Light. So the timeline is tighter than it might seem. The core reason Haskell feels clean is an age as a design philosophy. Haskell was designed by committee deliberately. OCaml descends from ML, which was originally a meta language for a theorem prover. Oh my god. ML's syntax was designed to be expressive and concise without context. Oh my god. Haskell syntax features scales better, yeah. Really? What the hell? So, chat, why do people like OCaml so much? Like low key, like obviously it has its benefits and all that. Like, Haskell has its drawbacks. But like overall, like this is just like no wonder it's so weird. It's old as hell. Are we dead ass? Are there any modern modern reimaginings of OCaml that are popular? Like, why is OCaml so popular even now? As far as I know, it was used for the Rust compiler initially. Like, OCaml has a really positive reputation. But maybe that's just from people who kind of look at functional programming in this lens of like, whoa, so cool, but haven't like actually tried OCaml themselves. OCaml is okay. Yep, bootstrapped into Rust around 2011. OCaml has a rare sweet spot, very fast native compiler. That's fair. That is actually fair, and it's a practical module system, arguably still unmatched, and a type system strong enough to rule out whole classes of bugs without being as demanding as Haskell's. Interesting. And you can use mutation. That's true as well. Haskell does make that quite annoying. Yeah. So I guess then Rust is the replacement. I mean, like not like a strong replacement, but like an informal replacement because like obviously Rust implements itself, right? So they felt that that was a good move. But like Rust has algebraic data types and pattern matching. So it takes the good stuff from OCaml that makes it suitable for this. In that case, I don't know if I will. Hmm. Okay, because like I thought OCaml like would genuinely be worth learning, as like this newer than Haskell, very popular, people seem to like it kind of language. But if this is the case where actually it's old and kind of outdated, then maybe just skipping to Rust is the logical step. But anyway, other languages include Reason, make it look like my JavaScript, there, Melange, OCaml 5. What about Rust? Well, what is Rust like? Lack. Yep. Rust's ownership of memory. OCaml has a garbage collector. Oh yeah, it does have a garbage collector. I don't like that. Rust type system is more complex. Yep. The complexity pays off because you have no GC. Um, and Rust is imperative first, which I do. Do I prefer imperative programming? That's an interesting topic to explore actually. So yeah, I mean, I'm glad I'm using OCaml and Haskell to kind of feel it out. Rusts are good. They lack some of OCaml's expressiveness, polymorphic variants, functors, module system that's less powerful. Yeah. Okay. What makes is OCaml's uh module system powerful just because it's written in Lisp? Like for those who don't know, if you look at my thing here, like this is literally Lisp, isn't it? Like this is the module system. Um, Yeah. I mean, like, I see it, like, they're not competing in the same space. I do care about what Rust addresses, which is no coverage collection, and memory safety, and just having things be nice like in OCaml and Haskell. So yeah, I guess Rust just fits me better then, because that is like my use case. Or like philosophy. So my other question is why, what makes OCaml's module system so powerful? Because people do have issues with cargo, and of course, like CMake with C++. I mean, C++ has no official build system, but OCaml is one of the things that is hard to appreciate unless you've used it, because concepts don't have clean analogs in multiple languages. A module is a named collection of types, values, and other modules that must exist as namespaces or packages. Yep, that's what I'm used to. OCaml's modules have types called signatures, and you can write code that's generic over a module. What? Functions over modules are functors. Makes sense, like a category. The killer feature is functors. Functions that take a module as input and return a module as output. Okay. Module type ordered equals sig type t. So module type, I guess, is like a framework for like a functor. Module make set. What the hell? So int set is a make set int. String set is a. Oh, that's really cool. That's so cool. I need to explore this further. Oh my days. Okay, my issue then here is that they're called modules. I don't think this is a module system. This is a like a class system, a struct system. Um, hmm. I mean, like if it says here. In fact, well, hold on. Yeah, what the hell? Modular expression equals struct? Why did I even do this for namespacing? So, like, I guess OCaml modules are like namespaces, but with functors built in. Yeah, I don't know. I think these work better as separate features, but that's really this is really cool, really interesting. I like this a lot. Haskell has. Can I say Haskell? Haskell has type classes. This has module type modules, which I guess aren't that different from type classes anyway. Man, okay. Sorry, this is a bit out of scope of my calculator project right now, but this is very interesting indeed. Okay, Scheiße. Anyway, let's get back to coding this thing. So, um, yeah, sorry. So we just do the things like this. So let our tokens. We just do tokenizer dot tokenize input in. I couldn't spell apparently. Is that correct? And then just do the same thing for each one. So we get our tokens, and then we get our AST because we are parser.parse tokens, and then we're evaluating result. Whoops. I think I should do like this then. It'd be evaluator.evaluate AST. Okay, result. And if it's an error, then this implicitly handles that. Nice. So let's just go ahead and input equals read line. Yep, in calculate input. And then we need to match this. Well, no, because I need to store the result, right? No, I just do match. That's right. So match, calculate input. If it's okay, then it's do it like this or like this actually. What's more like idiomatic? feel like this is actually cleaner, so I'll just do this for now. Okay, results, right? We want to print the results. It's a float, so string of floats as before. Results, and then call main again, right? Because it is recursive, so it'd be like this. And for errors, no, actually, I don't think I need to do this. I think I can just put this below now, right? Error, error. Who am I kidding? I'll just copy paste this from before. Yep. And then I just separate these out like so. And okay, I won't delete this yet, but let me just check this works first of all. Line 18. What's wrong? The constructor cam. What the hell? Error is a string, isn't it? Calculator is a string. What the? What the? What? We're passing a unit instead of a function A to B to C. How are we passing a unit? Is it because of this? Oh, I understand. This is being treated as part of this. So can I do to begin, end? Syntax error. Oh, it's begin match. Sorry. I am learning. I must say, as weird as this language is, it is quite fun to learn. God, I really regret saying that. Begin match. This expression has type unit. Is not a function. It cannot be applied. I didn't say it should be applied, but okay. Do I have to do this then? Or like in? So I think I can do. No. So do I do a semicolon? Yeah. Nice. Nice. Okay. What did Claude say? Put it here. Okay. I don't even, does this even, oh, because it wraps it in brackets. Yeah. I'm a bigger fan of the begin end because like I just find that a bit more clear to read. Okay. And then so my question is, can I print in between these steps? How did I even copy that? I swore I just did this. So if I just want to print this, right? Is that something? Is that can I do that? Let's see. Oh, cool, cool. I like this. I like this a lot. I do like this a lot. So then just do the same for the other ones. Um, parser expression. Yeah, that's the only other one there is, I think. Boom, bam, beep, pound. Boom, bam, 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 boom, bam, bam, beep, bap. Cool. And then for that, I'll also then therefore print an end line as well. Print end line empty. A bit of spacing and a file. Okay. 3 plus 3. Nice. Nice and you're nice. Nice, you're nice. And then I should make this a bit more pretty with the formatting. So print and line. Tokenize or tokens. I mean, for Haskell, what did I do? What did I do? Yeah, tokens, and then yeah. I didn't know that triple equals gave this, so I'll use that to take advantage of the font. Yeah. Oh, my back. Oi. Okay. Same thing here. Just move this and abstract syntax tree. And then similar thing. Result, I guess, I'll print. Uh, yeah. Let's see. Line 12, syntax error, because I'm probably missing a semicolon in these two places. Oh, my back is actually killing me. I need to. Yeah, what? Why? I mean, I've been sitting down for a lot today, but like, that's not particularly new in my books. C++, nice, everything works. So let's do ours again, 6.9 times negative 7/3 plus 2, I think. I messed it up. Like this. Okay. Something like that. Yep. Negative 29.9. Lovely. So, what is going on? Why did I do this? I mean, like, Claude helped me with, like, telling me to use this, but that's because I found I wasn't able to do, like, to just do this kind of workflow for some reason. And I'm trying to, like, pinpoint, like, well, we remember what exactly was stopping me. Um, Left IO do if verbose. Oh, it's because I had a flag. Yeah. So basically, I have this. I added a flag to my Haskell thing, which says if you want, it asks if you want to see the verbose output. So like, so do you want to print the tokens or do you want to just skip the printing? Um, and that was the Haskell approach to solving that, I guess. But then, is there a better way to do it though? Like, I could just define a separate function that like does the same thing here. But then the issue then is that like I'm technically duplicating code. Whoa. Because I can't in Haskell at least I can't just do like if um not verbose and then like wrap this like that doesn't work in Haskell because the control flow needs to continue from here. Um, let me see what's possible in OCaml though. I would love if early returns are a thing because that makes control flow just so much easier to process. So let's go ahead and copy paste this and ask Claude. Does OCaml allow? Okay, how would I make the printing here conditional on some boolean? Like how to affect the control flow? Pass the debug tool and use if. What the hell? Question mark debug equals false. What? Is the question mark like a default argument thing? Yeah. Make sure option label argument. So callers do calculate input or calculate debug true input. Holy moly, man. This language has such interesting syntax. Like, on God. That's it. Huh. If without else. Oh my God. Okay, so in Haskell, there's no if without else. If you have an if then you need an else. In this case, you don't. And that's why it works. But why? Why? The if without else is fine here because debug print returns unit. Sure, but there's no else here either. If without else expects unit. Oh my God, that's so cool. Why doesn't Haskell allow if without else? Oh, that's huge. That's actually huge. Like, no joke. Like, just that makes it so much easier to handle control flow because then like you don't need this bullshit. Um, in Haskell, everything is an expression and must have a type. If it's type A, so with match. In OCaml, if without else is also an expression. It just implicitly has else empty, which is why it only type checks when the then branches unit. And then this operator sequences it. So in Haskell, can I just not just do like if else and then on the else do a chain? No, no, because it's just a lonely operator. Okay, I'm gonna look into this like more deeply later. But whatever the case, it seems like we can do this if you want to. So question mark show debug equals false by default. Default. So we can just do if show debug. Yep. Then oh wait, begin then. Yeah, wait. Why do I even need to have begin here? Okay. I guess that's another reason then that it works in this language on a Haskell because you can just you can scope it like this, like so. That's it. That's actually it. Okay, man. Like once again, neither language between Haskell and OCaml is truly procedural, but like OCaml does do quite a nice job of making it seem so. Um, I quite like this workflow, honestly. Like this resolves my issue with Haskell to the point where you could argue this should be used in general. Maybe, maybe, maybe. Okay. Anyway, so if show debug, same thing for all of these. Yep. Okay. In fact, I don't even need to have this in this case. I can just do this. I think. All right. Um, pretty cool. I will just put it on a separate line anyway. Just a bit clearer. And that is that, I think. So by default, it'd be false. So if I were to run this, it should just not print anything. 2 plus 2, 4, 5 plus 4, 3, 7. Yeah, exactly. So now I just need to make sure I can pass whether I want to print debug or not. Look clean this looks, by the way. I mean, not clean like syntactically, I can't lie, but control flow wise, I do like this a lot. Holy moly, can Haskell really not do that? Why? Why? So let's go ahead and um, get this from the command line. So main will have two. Yeah. How should I do this then? I could just make show debug a global thing. That's better. Having show debug as a global value, global variable is better. So let's finally use the mutation feature in OCaml. How do I declare a global mutable variable? Because that's just, I mean, like it's for the scope of our program. Might as well. Ref dereference with exclamation mark. I actually want to kill myself. Assign with this. Oh, okay, I see. So that's how they're able to differentiate between the equals let operator and the equals comparison operator. Fair enough, I guess. Wait, so does JavaScript get its like equal sign and then double equals and like triple equals from this language? Dude, this language is so messed up. Like, I genuinely hate it, but I also love it at the same time. Like, this is insane. This is insane. What the hell? Dereference with exclamation mark. The Haskell analogy is IORef, but in OCaml refs are not wrapping in monads. Mutation is unrestricted. What? Wait, what? How does OCaml? Wait, what? Can you give an example of Haskell doing it? Wait, so Haskell accepts mutation? Oh my god. I mean, at that point, just like, why are you even using Haskell? Um, but I didn't know you could do this. Yo, any Haskell programmers watching this video, like professionals, like, do you guys use ref counters, or do you prefer to just do it the functional way with recursion? This is fascinating. Fascinating. Okay, so let show debug equal ref false, right? And then I don't need this anymore. Yep. And then it's quite simple here. I just need to here. Not this, sorry. Uh, where was it? Command line input. That's right. sys.argv.0. So let me, yeah, I didn't actually test this for my Haskell project. Nope, never mind. I did test it. Sorry. So the first argument, show debug assign equals. So we're using this assign operator. This operator is for assignment. I don't know why we use this. I'd prefer if it was like just an arrow or something. Oh, okay. Hello. Um, but whatever. There's so much to say about this language's choice of operators. So we want to have a Boolean expression, right? Hold on. To assign, we just do counter. Yeah, okay, that's fine. Okay, array.length sys.argv. Yeah, so it's a Boolean. So array.length of sys.argv is more than 0, and I assume that's how you do and, or would you use and with like a keyword? No, because and is used for like again here, like these things, right? For chaining functions or like chaining whatever. Right? Okay. So I assume it's this and sys.argv dot the first element equals the string. Well, okay. For now, I'll do it true. But I will accept other inputs as well, like you have t, true, 1y, etc. Yeah, seems good. Okay, let's see if it compiles. Uh, just build first of all. God's sake. Oh, whoopsie daisy. I need to do it visit. So show debug, exclamation mark. Dude, like what the hell? How did you not? Like would you do like equals false or something? Like this looks like this is okay, this is so bad. This looks like not show debug. Like chat. What the you have to be so locked in, I swear, to read OCaml and not like get confused. Cause what in the world, bro? Equals true. This expression is type string. It's not a function. It cannot be applied. What? I don't apply it. I can only assume I need to do something like this then. Assuming that this operator, like the double ampersand, even does what I think it does, which is the and. But let's just wrap these in parentheses for now. Type bool, not a function, can't be applied. I wasn't trying to apply it. So how do I interrupt the whole thing? No. All right. Boom, 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 beam, bap. No, sorry, boom, tap, tap, tap. Claude, help me. Yeah. Is this how I chain booleans? Or I combine booleans, whatever. It's a bug. This is always true. The program name is always argv0. Yeah, my bad. Oh, the program name is arg0. Oh, okay. So same as C. So there should be one, more than one. So there should be what? No, more than zero. Huh? Huh? Oh, the length is right. So the length is one with a zeroth element, right? So same as C. Okay. All these languages are getting in my head. You probably want this. No surprises there. Well, you say no surprises, but for some reason it doesn't seem to work. Oh, because I'm trying to apply it to main. Okay, now it should work. Awesome. So let's go ahead and June execute first of all. 2 plus 2 is 4. And then if I were to try and execute with this set to true, 2 plus 2, perfect. And just like that, I've literally completed everything that I had in my Haskell version. Yo, we are cooking. So let me just define something real quick. Let's actually I'll do it like this. Um possible. Yeah, because in Haskell, I did a string, sorry, an array like this, and then I did is it an element of? How do I define an array or a list? How do I define a list slash array in OCaml? Like Haskell, it's pretty damn straightforward. Linked list, homogeneous, type is int list, array contiguous mutable, one index. Yo, what? What the hell? An array uses these. Man. Man. Huh? The left arrow operator is used here to write to the array, not the equals. Dude, this language is. I love that this language exists because there are so many ideas that can be taken away from it. Honestly, if Rust wasn't so concerned with looking like C++, I think it'd be cooler. Like, this is crazy. Default to list, like in Haskell. Use array when you need random access or mutation. I don't, so we'll just use a list, right? The main difference is that you use semicolons or commas. Okay, so let's truth values equals true t t 1. I mean, these are obviously not crazy exhaustive, but just to get the basics. Yes, I totally could have just copy pasted my Haskell stuff, but whatever. We ball, don't need this. And then how do I check if something is an LM? Where am I going? Just left my everything. What is the OCaml equivalent of Haskell LM? For release list. List.member. Makes sense. So list.mem set argv1 on truth values should be correct. Okay. Let's do like y then. 2 + 2. Yep. And let's do June exact, just normal. Oh my god. It's beautiful. One more thing. I'm going to make this conditional as well. So if not show, if the reference of show debug, then do this. Yeah. And this just means that if you don't want to debug, then we get more compact like this, 2 + 2, and then like there's no sorry, I should probably zoom in. There's no space there. Whereas if we now do with 1 for true, then it includes a space for easier visual reading. Nice. We are literally done, bro. We're literally done. Git add, git commit, finish all the basic stuff, or sorry, functionality, and push. Perfect. I like this a lot. Okay, it's now been an hour and a half. I'm going to, before truly finishing, I want to go through some strategies to make this cleaner then. So I'm quite happy with this. I think this is fine as it is. Any notes for this then? So let's start with this. Can I make this nicer? Can I make this easier to read, or is it just how OCaml is? Because I want the type information. Obviously, I can make it implicit, but I didn't want to do that. Type alias. Okay. That'd be useful if I was reusing it, but I'm not. I meant more with the verbose type signature. That's not. Okay. And I can drop it, or just get the return type. Yeah, but it's good practice. Okay. Can't do anything about that then. This is necessary. Yeah, all this looks good. I could include like length and argv, I guess, but why would I do that? That's just not good. Okay, so let's go into our tokenizer first of all. function. What does function do? Function is just a way to match the function args. Yeah. So let's use this here. Or here, even. I'll do it here first, because this is a bit of a harder thing to read. So for this, I believe I can just do function. On all of these, even. Because the first argument is just that, right? Oh my days. So let's just build. This pattern matches values of type parser.expression.union operator, but a pattern was expected that matches values of type float. What? Huh? How can I partially apply this, by the way? Which looks at in a second. What? Am I just missing something? Equals function, and then this just matches the chars directly, no? Okay. See what? Let's just not take any guesses. Let's just see what the conventions are. Tell me every way in which I can make this cleaner. Because there's no point in guessing. I should see what people actually do. Open module at the top. Open parse.expression. Yeah. So I was wondering if I have to do that actually. Let me test this. Because can it not? Oh my god, I can't speak. Can it not just infer um what this is? It can. Okay. Okay. So yeah, so it can. So I just don't even need this at all. Okay, so I'll replace all the parsers. I'll replace all these. Parser dot expression tab. I think no. How do I forgot how I autocomplete here. That doesn't matter. Yep. And just repeat the same thing again here. And that seems to work. Cool. Yeah. Okay. I do like this feature a lot. I wish Rust and other languages. Well, I mean, I assume Rust doesn't, but like I wish C++ allowed you to just like not have to preface the entire enum. Well, not namespace, but like the name doesn't matter. But like if in context, like if I didn't I'd like it if instead of having to do like std endian little, like if the compiler knew that it wasn't an std endian here, it would just allow me to just put little, right? Like reads U32, like this versus having to do the full name. Because like I can use the namespace std like this, like that. Or even, yeah, like I could do this, and then I can do, but that's it. Like, I don't even know if I can do using like little equals std and little. Like, I don't even know if I can do that. Um, and then even if I can, like, I need to define it myself, as opposed to just having it built in. Anyway, just a thought. Um, okay, that's one thing. I don't know why Claude thinks I need to open it, but whatever. Also, it does indeed put the match and the pipe on the same line, so I will comply. I think it's just less indentation is better, and it doesn't affect readability in this case. For Haskell case, there is no pipe before it, so it's a bit different. Point three, since negative dot is just a float negation function, you can write this with h reduction. What do you mean? Function x to OK negative dot x. Okay, it said this again. Why can't I just use result.map? Okay, but it says to basically just stick with my lambda. Okay, that's what I'm doing. Okay, like, I guess I could get rid of this type signature, but to be fair, like, it's really defined here quite explicitly. So, okay, I'll remove it in this case. Um, for your second point, why not just use why not just use result.map? By the way, I get the impression that Claude doesn't understand OCaml that well. Like, AI just doesn't understand OCaml that well. I mean, I don't blame it because like it's a cluster fuck of a language, but like, what the hell? Like, what is going on? Drop redundant type annotations. You've just told me to do the same thing here and here. But okay. Indentation. Yeah. Final result with local open. Okay, so there are local opens. Let's open. I like this. I like this a lot, actually. Um. Also, my thing compiles without needing any open. It seems the compiler infers the namespace slash module. Okay. Results maps over an existing result, not a plain value. Oh yeah, my bad. Um, this just takes a float and wraps it in OK. Um, is there really no alternative to this? Well, I use fmap. Hold on, no, I use fmap. What does fmap actually do again in Haskell? Like, I look, can't remember. Fmap Haskell. Find functor f takes an a to b, an fa, and just an fb. Huh? Really? So what did I do here for my evaluator? Fmap right dot plus. Oh, it's fmap right dot plus. Um, so it takes a plus, which is our a to b, and then it should take an fa. Sorry, no, fmap takes the function right. which is an A to B. Fair enough. I mean, it's an A to a, let's say like an M of A, and then it takes an A and a B. Yeah, no, that's fine. But that's for fmap. For write, we can't do the same thing. I could define fmap. I think I will, honestly. Let fmap equal. It takes a function f of type. I think. How does this work? Is it like this for generics? Yeah. So it's this to this. And it takes A. Yeah. And then it returns a B. Can it be generic? Not really. Okay, let's make it a float then. So from a float, yeah, I'll just do fmap okay. Like kind of like what's it called? Claude suggested initially for now, and then we'll take our um function composition shouldn't be a problem. So fmap okay. We want to result. So we take a float x, let's say, and we return float string result. And let me float or error equals float string result. Okay, let me do this as well. So copy that and across our file here. For every instance of float string result, replace that with our thing that did not copy to my clipboard, float or error. Okay, just to unify that. And same thing here. It just takes x and returns OKX. That's it. That's literally all we need just for it to wrap. Um, in this case, because we made it specific. In which case, I should be able to well, first of all, let me build. I'll probably like an unused warning or something. Unbound value string. What? Did you mean stdin? No. What? How's string unbound? How do I define types actually? I think I used it here somewhere. Or here even. Yeah, type. Sorry, my bad. Um, type. Let's see. Oh, okay. I didn't get any unused warnings. So then I should be able to just replace this with fmap okay. Nah, what? This is literally just the same as just doing fmap okay. Like that this is wrong. Um God, this is testing my brain right now. What does it do? Fmap with okay. Then it takes a second argument, which is a float. Yeah. So we're just embedding that inside. And then that needs to be applied to a thing. Because with function composition in Haskell, yeah. So actually, this already kind of works. I don't think I need this. I'm pretty sure. I think all I need is okay, and then some way to to compose this operator, and then it's implicitly applied to x. So x gets applied to this, and then which thing gets applied to this. Um, I can't do this without function composition. Without yeah, without declaring this. Scheiße. Okay, does does OCaml have a function composition thing like Haskell? And by thing I mean operator. In fact, can I define it manually? Like, what does operator even do? Obviously it queries, but oh, it does. Applied function, sorry. Function application, like Haskell's $sign. Or Haskell's dot. You can define one trivially though. Oh, sorry. So it does have this for application, but not for dot. Does it matter then? Like, I guess I can just do this, right? Is that any different? Haskell has a triple. What the hell? I don't even know anymore. Um, FGX equals f of g of x. Yeah, but this should work. Nah, no, it wouldn't work. It wouldn't work. But I can define a custom operator. So sure, let this, I guess, equal sorry, that's a name. So it takes an f function, g and x, and it takes f of g of x, right? And then I should be able to just do this. So that actually work. This expression should not be a constructor. The expected type is a to b. Adds one, then double. Yep. So apply this and then wrap it in OK. So then what's wrong with this? Also, if there's a double at thingy, then can I remove some operators here? Some brackets even. Like can I do this? Okay. First I'll fix the other thing. OK is being parsed as OK, which tries to compose OK, but the issue is actually operator precedence. It parses as Constructors aren't first class functions in OCaml the way they're in Haskell. You need to wrap it. Flippin' hell, man. Flippin' hell. If you want OK to be useful as a function, you can either expand it as a definition site or use just OK. Okay, what did this thread say? I can use this. Here, function.compose. X to OKX. Yeah, because I couldn't use it as a thing. I mean, at that point, like, what's the point? Like, if OK can't be used as just a normal function, then screw it. Well, I guess OCaml just doesn't have the same syntactic sugar. I mean, it's not even syntactic sugar, just the same semantics that makes it so nice to use. So we'll do OK, and then I can do, I think, this on this. I assume. No. It's applied to 0 arguments. What does the at even do? What? What does the double at operator do? Why is it whenever that the at sign is used in a programming language, it's never in like a way that means at? F and G, F at G at X, the same as F at G at X. Sure. So I want to do like this. Syntax error. Oh my god, because I need to wrap this as like an operator like this. Bro, at this point, like, I feel like brackets are just less less messy looking. And of course, this isn't a function, so it'd have to be function OK or function x to OKX. Oh my god, I feel like a clown. It doesn't even work. What? Similar idea but flipped. Okay. Funny how these two are like meant to be the reverse of each other, and yet they're just not even remotely the same. Uh, I mean, function x to OK. What did I do wrong here? Function x to OKX. What's this issue? It was a flow-through error. Huh? What do you mean A? It's clearly OKX. So what, I'd like to do results for OKX? I guess. Okay, you know what? Crazy stuff going on here. Let's just do what it was before, which was just like this. Pretty damn simple. It's a shame we have the parentheses, but obviously they're not that big of an issue anyway. Try again. Okay, so let's just go ahead and remove all this stuff then. Um, yep. Okay, because we don't really need that there. I think that's it. I can obviously like I could abstract this away, but I feel like it's just not really worth it in this language to do so. Um, yeah, I don't know. No point. There's no point. Okay, this is quite clean. If t equals 0, full stop, then error divided by 0, else okay. Seems fine to me. And yeah, this seems pretty good. I do like this, of course. Uh, I'm not using this, right? Yep, nice. And then for this one, just need to move this back. Oh, also function, sorry. How do I use function? the keyword. Please do not think I meant like functions. Contemplating. Okay, function is syntactic sugar for a simple single argument function that immediately pattern matches. These are equivalent. Yeah, I thought they were equivalent, but they don't seem to be. Is it because I have too many arguments? So like here, if I get your new operator, I have one argument, but if I try changing this to function, it pisses itself. Unbound constructor negative. I'm guessing it's because the same inference doesn't happen here. So I would need to do parser dot expression dot negative. Is that correct? First of all, yeah. So I'm guessing this is the same then, where this does work, but only if I do this. No, what the hell? This pattern matches values of type parser, operator. Yeah, what? So why does it expect me to do float? So why doesn't it work here? Matching on the next argument, a float, not an operator. You've already named the argument operator, so oh, right, that's right. My bad. So I need to not define this, which kind of sucks because it means that I can't. Hmm, like it doesn't know. It doesn't say what the type is. Uh, I guess it's fine. Like you can see it here, right? Like in the parser expression dot negative. Yeah, I guess that's okay. But that also means I can't like use inference, right? Because that wouldn't make sense. Does this build first of all? Not even. It still expects type float. Did I not save? I did save. What did I do wrong? Uh, Either drop the name parameter and a function handle it. Oh. Oh, okay, so I actually need to include this. I understand, I think, why you do it like this then. Because the function just takes it. So like function is like a implicit fun x match x with, right? I guess that's what would make that make sense. In fact, does it say here? Yeah, literally that. Okay, no, that's fair, and that's good because that means that we do have the types after all. Nice. Okay, let's do build. Should work perfectly fine. Nice, and then let's just go ahead and see if we can do without this then. So D to F boom bap 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 beep boop. Please work for the love of Christ. It works. Let's go. So that I mean it just means that I don't need to yeah just a bit less verbose. And I can also remove the name, which also helps with removing verbosity. Um, yeah, and now our type signature looks a lot more like Haskell-y, which I find nice. I could put them on the same line, but this doesn't, so I won't do it either. I mean, the good thing about AI is that I assume AI follows good conventions. Obviously, for a language like C++, maybe not so much because there are different ways you could do the same thing across the community. But for functional languages, where best practice is more like highlighted in the community, I think this should be fine. Okay, this should build. Nice. And yeah, this is looking good. Let's just run the whole thing through ChatGPT again. Claude, sorry. I just like saying ChatGPT. Evaluate this for cleanliness and best practices. Let's see what it says. This is quite clean. Good stuff. Minor issues. Filter errors, type alias. Not wrong, but OCaml is more idiomatic to either use directly or define a proper type in a dedicated module. Thin aliases like this don't pull their weight. I understand the sentiment, but no, I disagree. I mean, like in Rust, you'd even like wrap it in like its own thing. I mean, I like in this case, it doesn't match, does it? Although this is actually, to be fair, this is being exported publicly, which isn't ideal. Um, and like, what if I wanted to improve the error? Okay, for the first points, yeah, but module printers own module. I could do that. I could do that. I'm gonna keep it as it is, but just change it to or error like this. I think this is how I do it. So just float or error, right? Or just even better, just do this. No. I forgot how it did it, how it said to do it. Here. Oh, the title's good before as well. Fair enough. So it goes like here then. Yeah, nice. I think that's quite good. Um, yeah, should be okay. Um, what should have like collisions later? Shouldn't do though. Minor issues. Uh, d equals 0 is a float equal to comparison. Technically fine for checking the literal zero, but worth knowing that this will have behave unexpectedly for NaN inputs. If that matters for your use case, float is NaN, handling is more robust. For a calculator, probably fine. Okay, what does float NaN even do? Because I thought NaN meant not a number, literally. Exhaustiveness on get unit operator. If you add new variants to unary operator binop, these will produce a compiler warning, but not a type error at the call site. The compiler warning will catch it. Yeah, that's why I am using a functional language with algebraic data types. That's kind of the whole point. Yeah, what the hell? I have like a headache coming. Let's be careful. Get binary operator. The parens around get binary operator are necessary. Are they? Okay. I don't know if I like that though, because it's all clear that I'm applying it to it. No, I don't like this. I'll keep it as it is. Return time annotations. These are explicit and helpful given the current structure. Keep them. Yo, I have a bump on my forehead. I'm not sure if this is normal or if it's because I have a headache coming on. Whatever. These are explicit and helpful given the query structure. Keep them. Okay, so just check this as well. Yep, things like 0/0 or square roots, -1. A calculator will just return not a number. Yeah. Again, for the sake of a calculator specifically, it should be okay. Okay. Otherwise, I'll just pass it on as default behavior, like whatever the operator does. Because like, why not, right? Is that it? That's it. Cool. So we're done with this file. Nice. I like this. Cool, cool, cool. Very cool. So let's go ahead and apply this whole function thing to the other files. Um, so instead of match tokens, we'll just do this. Oops. And then also fix the indentation. Uh, yeah. Oh no, don't do that. I wish my auto formatter was a bit more reliable, but whatever. Yep. Um, yep. Oops. Boom, 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 boom. Boom, boom, boom. I want you in my room. I don't refer to input after this, so that should be okay as well. Okay. Is that readable though? Not really. I guess having like an extra space here is actually kind of good, because otherwise I can't actually read what the hell is going on. Yeah. Okay, I'll apply the same logic to these then. Again, like you have the bars. Can I redo? No? Okay. Nah. Screw it. You have the bars. I think it's fine enough. Uh, Speaking of which, I'm just going to compile this as well real quick, just to make sure this actually is doing what I think it is. Uh, this should actually work fine without parentheses here. Okay, let's see. Bloody hell, please, please, please. Oh, typos, typos, typos. We're on, by the way, 2 hours and a half, 2 hours, 13 minutes. Let's go. Yep, it worked. Good. Uh, that's fine. We're not matching. Okay. Okay, that looked cleaned up. And then let's go to the last one, tokenizer. I already use a function here, that's fine. I'll just remove the indentation here and here. No, keep it here. Or don't, hold on. I do. Because we imagine that function would go like this. Yeah, okay. Cool, 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 cool. Nice. Seems good to me. The other thing was this, the result.map. So let me just check this actually compiled so far. Did I make a mistake somewhere? Yep, okay. And why can I not just do this? Like this? Oops. Oh, don't do that. It's weird. Let's copy this and ask Claude one of our last questions for today. Why can I not simplify this like I can in Haskell? I mean, I assume this double colon operator is just a normal operator. Constructor. Oh my boy. Oh my boy. What is the difference between a constructor and a function in OCaml? Because like right now the difference is really screwing me over for both OK and this now. Constructors are not first-class functions. You can't partially apply them. Some is a special case. Aww. Would OCaml be better off if constructors were just functions? Okay, let's see what the actual trade-offs are, please. Or just gonna give up on me. Oh boy. Haskell does this more ergonomic. OCaml's constructors carry more information. A constructor can hold multiple unlabeled fields without a tuple wrapper. I see. Is that it? But there are function pattern matching optimizations. Okay. Well, it is what it is. It is what it is. So cool. I believe we are done. Um, hold on. This is double equals. Can I make this just a single equals then as well? Or should that be a single equals? Back my elbow. It hurts. Jesus Christ. Okay, let's do 3, 3.3, 4.4. Yeah. Exception failure floative string. Oh well. That is the one like case I didn't really cover properly, but I cannot be asked to check it more closely. Yeah, I don't like this. Like it looks like an assignment, but nah, it's fine. It's fine. This is fine as it is. Okay. Okay. So git adds, git commit, um, cleanup, really, and then git push. Okay, 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 okay. Let's have a look at our project now. So I'll go ahead and add a README, finally. Just go ahead and pretty much just copy this. Um, yep, command line calculator in OCaml. This is a very simple command line calculator that values expressions programmed in OCaml. By running the compiled app, yeah, usage, calculator, .exe, I guess. Yeah, screw it. Run the executable to get started. Yeah, whatever. So usage. Oh right, colon Q exits the program. I forgot about that. I mean that was more for like GHCI. I don't think it matches as much for this, because yeah. Um, okay. Uh, oh right, but I will get slightly different outputs in this language. So let's go ahead and run our thing. Why did I even open it here? No write since last change for buffer. Oops. Oopsie daisy. Does it still build? Okay. Same thing. Okay. Just re-release. So let's run our app. June execute or not. June exec dot slash calculator dot exe. Bin, sorry. Main dot exe, I guess. Um, so what's our example? 647, 67. Oh my god. Is a 13.0. This expression here, not even. 29.9, none of this stuff. So it's actually more correct than the Haskell version. If I do with verbose output, so let's exit and true. Same things before, I get this. Which I'll just. So what am I doing? Yeah. Looks a bit more verbose because not a lot of things on one line, but I do prefer that anyway, so cool. Um, yep. There's no JCI, so remove this. I change this real quick. What's the thing called? OCaml. So change that to OCaml for the issues. Uh, uh, uh. Yeah. So knowing now about like the whole like ref thing, I could use Haskell, like really. Um, like now it's more feasible for me to use Haskell to expand this, to be honest. But whatever. So I first made. Okay. Interested in the implementation of tooling for programming languages. I figured that this would be the perfect place to start. What? I figured that trying to implement a simple CLI calculator would be a good start. I've already implemented a similar project in Haskell, and link that like so. Oh my god. Which is here. And since I wanted to learn some OCaml and see what all the hype was about, what all the hype's about, I decided I would also try implementing. Okay, what? And I then decided to learn some OCaml and see what all the hype's about via this implementation. Let's say. Unfortunately, Haskell don't need this. Okay. In fact, I need to update this README now to link to my OCaml project. Unfortunately, because it's a game, because I'm a scope and the only two constructs are, so I don't tend to extend the functionality of this program. However, I've been thinking of making it more. So instead, I've recreated, I've made a similar project in OCaml. And also want to take it even further in Rust someday. Yep. All right, OCaml. What's that? GitHub Copilot. Sorry. Yes. Later, I plan to also do a similar project in Rust, although with many more features, since I want to consider Rust as my main language going forward, replacing C++. That is, until an even nicer language comes around. Yep. Cool. So let's go ahead and commit that. And we should have it here now. Yep. Okay. I could probably, did I do a release for this one? I did actually. Okay, I'll do it here as well then. So it's just initial release. I'll use capitalization because this isn't Wikipedia. Version 1.0.0. Just copy paste this stuff. Use my own tricks. First quick release of this, calculator, technical for Windows, only supports basic expressions with operators plus, minus, times, and divide, as well as surrounding subexpressions in parentheses. Input true to the app in order to display everyone's output. Yep. And then I assume that's it. Right? I'll just rename it to calculator.exe, and publish. There we go. That is the first thing of OCaml. So I have pretty much finished. You can see here we've got lovely OCaml languages. And then here we'd say Haskell, right? Yep. Love to see it. And now on my profile, I can say I have used OCaml in a project. Let's go. Ooh, do I put it, replace it instead of Haskell? I think I will. So goodbye Haskell. Unfortunately, OCaml is just cooler. for aura points or whatever. OCaml. Yep. Looking good. Oh my god, I made a lot of contributions this year. Or in the last year period. How many today, actually? Seven today. Cool. So let's go ahead and edit my README as well. Because now I can say I've dabbled in OCaml. So take this. Looks like Zig is next on my list of languages to learn. Yeah, I've dabbled with Rust, dabbled with C, obviously. I'll put OCaml above C because I've done an actual project in it. With C, I haven't really done too much in it. Yeah. So just copy paste this template, paste it here. OCaml example 1. What are we? Wait, what? Okay. Okay, sorry. So the link is oh right, because we put this here. CLI calculator, right? And the link. Yeah. Okay. And then for Haskell as well, actually. Uh, one of my examples, image to ASCII, Wordle solver, and oh, I already have the CLI calculator there as well. Okay, cool. So, anything I can say about OCaml? So before, I said, this stands out to me for appearing to be a more practical Haskell, although I'm yet to confirm that. No. I do like a multi-paradigm language. It's not. It really isn't. It kind of mimics it, but multi-paradigm is a lie. I mean, like, I guess you can, like, write code that looks procedural, but, like, from, like, in that sense, Haskell is also multi-paradigm. Like, you can make it multi-paradigm. You can make C++ look functional. Like, I guess if you... Well, I guess you can't, but whatever. Um, yeah. Stands out to me. A descendant of ML. It is full of many fascinating features and design choices, but its age does show. It's lovely to see. Lovely to see. What do you? It's lovely to see. It's cool to see. I say lovely. It's lovely to see how it has influenced Rust. And since I don't, and since I'm not a fan of garbage collection, I will just opt to use Rust for projects where I would otherwise, where, oh no. Yeah, well, no. And I'm glad Rust implements so many of its features without relying on garbage collection. Nice. Cool. Preview. Yeah. OCaml. Hello, OCaml. How cool. I can now say I've used OCaml. How many people can say that? Lock in, guys. Lock in. Um, I need to add the thing as well. Skill icon. OCaml. What a lovely sight. Rust next to OCaml next to C. Beautiful. And then you got TypeScript and JavaScript, but we don't talk about those. Can I say I've used OCaml properly? Like I guess I've used it as properly as I have Haskell, because like I have made an app now, which is a calculator. Like that is technically a thing. Nah. Tell you what. Yeah. I'll just update this first. So looking at 2:35 now. 2 hours 35 minutes. That was productive, I would say. Obviously finished everything, so that's good. Um I'm going to keep working on this. So now I could shift to Rust, but I'm not gonna change to Rust just yet. I think I'm gonna keep on OCaml. Because I want to play around with the mutation that it offers. Obviously I've used it just now, but I specifically want to implement variables and maybe function custom functions. But that really just depends how complicated it'll be. But yeah, I'll try to implement variables and functions for my calculator. By functions, I mean like cosine, sine. By variables, I mean like you can store stuff, and that would be pretty cool. Yeah, yeah. And then maybe at that point, maybe I could even try letting people define their own functions. But then I need like a proper type system, and it's possible. Yeah, I don't know. I'll see. But anyway, good work today. Subscribe for more.